So what we're going to look at this morning is the area of circles, then the area of parts of circles. So here we've got a semicircle, here we've obviously got 3/4 of a circle, and here we've got a sector of a circle with a little symbol here called theta, which looks like this, and it stands for an unknown angle. But obviously I've given you the value of that unknown angle. So let's start with the area of the whole circle. So when we were looking at circumference, what was the formula for finding the circumference of a circle? Let's put that up here. What was the formula for finding the circumference?
Diameter times pi.
Yeah, so pi d. Pi times the diameter. And we know, don't we, that obviously pi is that ratio between the circumference and the diameter, which is why we can multiply the diameter to find the circumference. Now, if you are given the radius of the circle, you can either, change it to the diameter and use pi d, but there is another formula you can use. 2 pi r, well done, 2 pi r. Now, one of the things to notice about these formulas is that there are no index numbers, okay? Because these formulas are going to give you a distance. So one dimension, like the distance around a rectangle, one distance. Remember, obviously you could open it out and make it one line. So one of the confusions is that once students have learned the formulae for circumference and then they learn the formula for area, they get them mixed up. But there's a simple way to remember. So the formula for finding the area of a circle is pi r squared. Now, that's a good way to remember that this is formula for area, because area is in units squared, isn't it? So we have got a squared sign in the actual formula. So that's a good way of remembering the difference. Okay. So, again, what we do, formula, values, yeah, so formula, substitute the values, do the calculation, solve it, yeah, do the calculation. So let's put our values into this formula. So the radius is here, okay, and the radius is 23 centimetres. So our values are going to be pi times 23 times 23, because obviously r squared is the radius squared, which is 23 times 23. So you should have your scientific calculator out, put your value for pi in. Remember, it might be a second value, you might need to press your shift button, or if it's a button on its own, you can do it. So what is pi times 23 times 23? Tyler?
661.90.
Is that rounded to 2 decimal places? Yeah, because what's the next digit?
2.
Brilliant. Okay, so that's centimetres squared. So really, once you know how to substitute the values into the formula, this is really straightforward. You literally just do pi r squared, pi times the radius, whatever the radius may be. So if the radius was 14, you would do pi times 14 times 14. If the radius was 90, you would do pi times 90 times 90. Obviously, if you are given the diameter, you do need to halve it. Yeah. So if you're given the diameter, say the diameter is 40, you have to halve that to find the radius. Okay, any questions about that? It's very straightforward. Once you've worked out, and we did it with circumference, how to insert values into the formula, it's fairly straightforward. Everyone all right? Okay. Right then, let's have a look at this one. Now, what is that shape?
Semicircle.
Semicircle, that's right. So we know that it's half of a full circle. Who thinks they might be able to tell me what the formula is going to be then?
Is it going to be pi r squared divided by 2?
Well done. Pi r squared divided by 2. So the area of the semicircle is pi r squared divided by 2. Okay. Now, one of the difficult things about this though is if you are not careful, your calculator won't do it properly, because what it will do, it will divide the last bit by 2 because of BIMDAS, okay? So make sure that you are putting it in correctly. So your values are pi times the radius, which in this case is 15, times the radius, which also in this case is 15 again, and then you divide it by 2. So pi times 15 times 15. Divided, yeah, and then divide that by 2. It's always the safest way to do that. Because sometimes with the brackets and stuff it doesn't work. Yes?
I think it's 5,301.437, but that's not round.
No, that's not right. Because 15 times 15 is 2. Think about this. You can actually kind of give yourself what I call a ballpark figure. You can kind of sort of work out what it might be. 15 times 15 is 225, isn't it? Okay. Times pi, which is approximately 3, is going to be approximately 675. And then if we divide by 2, it's going to be approximately 330 something.
353.43.
So 353.43 centimetres squared. There we go. Okay. So again, it is a good idea to just sort of think about it before you put all the values in. Okay. Here, you've got pi times r times r. Now 23 times 23, okay, we don't know exactly what that is, but 25 times 25, you could approximate that, couldn't you? And then times it by 3, and that would give you the answer. It just helps you to know if you've got the right answer. Now this one here, what fraction or percentage of the whole circle have we got to find the area of?
75%.
75% or 3/4, that's right. So, a couple of ways of doing it. You can either, if you want to, you can convert the fraction to a decimal, or you can leave it as a fraction, okay? So what do you think the formula for this one's going to be to find the area? Yeah.
3/4 times pi r squared.
Well done. 3/4 times pi r squared. That's right. Very good. So, again, because obviously we've got to find the whole area, which is pi r squared, and then if you multiply the whole thing by 3/4, that will give you what you've got. You could also put 0.75 times pi r squared if you wanted to. But if your calculator can do the fractions, that's fine. So let's put the values in. We've got 3/4 times pi times 20 times 20. Let's have a think about this. Let's do a ballpark figure before we actually do it. What is 20 times 20? 400. 20 times 20 is 400. Times that by 3. 1,200-ish. Okay? Because obviously pi isn't exactly 3, but we can do a ballpark figure. So 1,200, and then let's multiply that by 3/4 or find 3/4 of it. 900-ish. So if your answer is not near 900, you probably need to put it in again. So can you do it for me and see what you get? Max?
942.48 centimeters squared.
Well done. Centimetres squared. Okay.
48, yeah, well, you want me to know.
Great, so is everyone with me so far? Good. Now then, let's have a look at this last one. This last one is a little bit more complicated, but it's not any different really to this if you understand what we're doing. So, if for this one, I had to approach it like this, what is that angle? 270. Okay. And what is the whole revolution? 360. So what is 270? Do this on your calculator. 270 over 360. What fraction does that simplify to? it simplifies to 3/4. So that's what you've done. So for this one, the formula for the area of a segment is what, do you think? Who thinks they can give it? It's got to be a generic formula, remember. It's got to fit any angle. That's why we use a letter for any circle. Go on then, Jasmine.
It would be 60 divided by...
That's the values. What would the formula be? Because you're on the right track.
Would it be 1 6... Oh yeah. Theta time...
No, theta.
Divided by...
Circumference.
the 360.
360, that's right. So it's theta divided by 360, which gives us the fraction of the circle that we need to find, doesn't it?
Yeah.
Because here, theta was 270 divided by 360 gave us the fraction of the circle we needed to find. And then what do we multiply by?
We multiply
Pi r squared. That's right, pi r squared. Okay, so that's your formula. It doesn't matter what theta is. Theta could be 15, theta could be 297, theta could be 42. In this case, theta is 60. So, what is my next stage? What values do I need to put in? Lachlan?
Put 60 over 360.
Well done. Times pi times 10 squared, yeah, times 10 squared, that's right. Times 10 times 10. Okay. So, what does 60 over 360 simplify to?
0.16.
Yeah, what's that as a fraction? 1/6, that's right, okay. So, but obviously you don't need to simplify the fraction because your calculator will do it for you. So 60 over 360 multiplied by pi times 10 squared comes to?
52.36.
Centimetres squared. Okay. Stop it for me then, please.